Okay, questions 10 and 11 were to do with the stack. The two functions that we form in the stack, push and pop. There is a third function, peek, okay, where we don't adjust stack pointers but we look down the stack. Now we came across that when we were messing about with parameters that have been passed using a stack, and also local variables are often stored on a stack as well. So you look back down from the stack pointer to get to your parameters and your local variables for a subroutine. It makes it simpler to, when you remove the stack frame when you've ended a subroutine or a function, to get rid of local variables, if that's how the language is doing it. Okay, but let's just look at the two basics. Okay, so remember, we draw a stack vertically, but often actually they're physically, I wish this had let me draw better, they're physically implemented. Get lost, moving down in memory sometimes, but we'll visualize it. It's all about visualizing. Okay, now what we need to think about is the stack pointer. Now in general, the stack pointer points to the next free space on the stack, so it points above the top of the stack. Okay, so this is our stack, there's nothing on it, so let's have a look at pushing an item onto this stack. Okay, it's like a stack of plates, or remember, stack of lemmings, as I described once. Pushing lemmings on off a cliff and popping them back off of a cliff bottom. It's a weird analogy, it sort of works. Okay, so the push algorithm, the first thing we've got to do is make sure that we haven't run out of stack space. So if we have a marker to say, okay, this is the top of the stack can't be at this level, no more than these items. So we check to make sure that the stack point is below that top position. Okay, and also we'll have a bottom value, which I'll draw on here, which is only relevant to the popping. Okay, we don't worry about what's happening at the bottom of the stack when we're pushing items on. Right, so we do a test. We say, okay then, as long as the stack point is below the top, let's put our item at that position. So let's just say I put on, I'm using letters tonight, I don't know why, I just am. So we push a T at the current stack pointer position, and then we move the stack pointer up. As simple as that. So if we were going to do it again, oh, so the stack pointer is now there. Add a new item, it goes where the stack pointer is pointing, which is the top. So we'll add a new item, the stack pointer moves up. Okay, still less than top. Add a new item, it goes there, the stack pointer goes up. So that's the last free space on the stack. So if we add another item, H, visualize it as a H. It looks like a H that's married an M and produced offspring, but it isn't. It is a H, in my mind anyway. Right, so we move the stack pointer up. The next time we try the push, okay, now I've got here in my algorithm less than or equal to, so this is the top, is pointing to the last free space. Okay, so I can put another item in, get off of that, but then the stack pointer goes above. Okay, so this might be some protected area of memory, or it might have another stack, or it might have another, it might be some variable space, or it might be code space, whatever. Okay, so the next time that we run, we say, oh dear, to this, and we, again, the example will expect it to output an error message if the stack is full. Not that that's a very practical thing to be doing. Okay, you would indicate using Boolean returns, probably. Okay, so oh no, stack's full. Alright, so that's pushing items on a stack. The opposite, the pop, remember we can only access the top item on a stack. Okay, so let's just go with the stack how we've got it at the minute. So the stack point is pointing up here. We say pop. We check to make sure that we are above the bottom marker, okay, which is down here. And then because the stack point is pointing at an empty space, what we need to do is drop it down. I'll do it on the right hand side here, and then retrieve the item that is at that position, so the X comes off. So the stack pointer is pointing at X, but when we go to add something, that's where a new item will go. Okay, so if we remove another item, again we check to see if the stack is at the bottom. It is above the bottom value. Drop the stack pointer down, and then we'll retrieve the offspring of H and M, not the shop. Okay, and we just keep dropping the stack pointer down, so eventually the stack pointer is going to go all the way down. Okay, and we'll get into that situation. Alright, and that's it. Simple.